website. Okay, so welcome to EGR 2208 Engineering Material. Make sure you sign the attendance. All right. Okay, class attendance. You come in 15 minutes after, you consider late. After 30 minutes, we start, you consider absent. You need to have 80% attendance throughout the semester. Huh? Okay. So we did confirm our schedule, right? So we only start lab after Chinese New Year breaks, right? Later, maybe I'll brief you guys on the lab report format or the expectation before we go into details here. Okay. Now, if you log into the Canvas, you will see the lab sheet. Let me show you the. Go into Canvas. Okay, you go to Engineering Material Canvas folder. Okay, you will see the lab manual here. Right? You'll see the lab manual here, and the lab marking scheme is here. So you submit your lab report, you go to the assignment here. Then you go to the lab report, you submit, okay? So lab report, you base on all these criteria, right? These 4 criteria. So you have title, introduction, material, data analysis, discussion, conclusion, literature review, and report format quality. So these are the things. Then you click here to submit your lab report. Okay. Okay. So from time to time you have announcement here. So if you miss out the earlier announcement, you go here and see the welcoming message lah. Okay. And all the material is available. For example, each chapter we will have 11 chapter here. So each chapter already upload the tutorial question here, right? So if you click inside here, for example, you look at chapter 1, tutorial 1, you click here. So this actually is your note, your note for the class. So what you do here, you can just follow on. For example, if you download this one earlier, you can just come to the class and you write in any notes you want. So this one actually go parallel with my PowerPoint slides, right? So again, some of you are audio learners, you can just listen. Some of you need write something to memorize or to learn the knowledge. Okay, so these are how we do. Okay. And from time to time, it's good to log in at least once a week. Go inside here and see what is already updated here. So each class we will record. We will record the class. Then I will upload the file into YouTube channel. So you will see the link below here. Later I will open the link for you. Okay, so you'll see the video link here. So you just click and then you go to the YouTube channel there. Okay. Okay, so let's go to the lab report expectation or structure first. So at least you know what you should do when it comes to lab report. Again, don't confuse this module with other module. If, for example, statics, you need to ask other lecturer what is the expectation, right? So for engineering material, the lab session will be handled by me. So you follow my marking scheme. Okay, so the first one is a cover page. Cover page is the later I'll upload another new format of cover page. Right. This semester onwards, we need you to sign somewhere here. Okay. Once you submit, maybe no. No, this one no need. Cover page, you do the normal one, the Inti logo, your name, your group name, and something else lah. The manual, the module, all these things. So this one no need. This one later. After you submit, make sure I return the feedback to you. What happened to your lab report? What happened to your assignment? Then you need to. I will attach one new copy, one new cover page in front of this one. Student feedback cover. You need to sign somewhere here. So this is after maybe week. This one maybe week 14. This one will be what we are doing in week 14. So this is first cover page. Then you go into your experiment. Experiment 1. So there's a title there. It's like your SPM lab report. Same title. Then the equipment and so on. All right. Equipment. Then your method. Okay. Okay. So maybe you follow the marking scheme. So it will followed by the first one, the title, first experiment. Then you do your literature review. Means you read books. Literature review. Okay. So this is theory. Mean this one is all a theory. You go and read textbook on that particular experiment. For example, if that one is material properties, you need to write some theories about 2 pages on that particular things. Then you need to do citation. Citation. Okay. What I mean by citation? For example, still have mechanical property of, for example, a value 10 something. This statement you read from a textbook. So you put a reference there. Then you need to do this is a citation. Then the last few pages of your report reference on last pages of what is this? Okay. Now later I will show you how to do this one. So we just discuss what is the general structure first. Cover page, then go to experiment 1. You'll do your literature review theory part. 2 pages. Then you go to method. Methodology. Methodology or method is how to conduct the experiment. Means step 1, do what, step 2, do what, step 3, do what. This basically is everything inside the manual already. You just need to copy, put into the report. Okay, so this one, we expect you put photo with caption. Features 1, what is this? Right? You need to do something like this. Remember caption. Okay, so if you don't put caption, you have a very low marks in your lab report. Or the way you write it, you mix between experiment 1, experiment 2, you mix around, then you have a very low marks experiment. You do experiment 1 by 1. So you don't mix experiment. Let's say you have 7 experiment. You have 7. You need to repeat this 7 times. Okay. So literature review, So this one, we expect got formula. This one, formula for your theory. Formula, then some statement, some theory, something about that particular experiment. Okay, this one is from textbook one. Right? Methodology is you copy from the handbook, the lab handbook, which is I will show you in the canvas. You just copy the steps. What you need to input is the photo. So when you conduct experiment, take photo, then you put inside there, then you label figure one dot what is that? For example, impact test of sample one. For example. Okay, caption. Okay, this is about methodology. Then after that, you go to result and discussion. You put together result and discussion. So here what we expect graph, data, then you discuss. Okay, so this data analysis, we expect there's some data analysis. So if you need to calculate something, you cover your calculation here. So you only need to show one sample of calculation. Let's say sample. Let's say you have 10. Let's say you have 10 data. You have 10 data. 1, 2, 3. Then there is a calculation for A, B, C. You're using the same formula. So you include how you calculate how to get A answer. You show how. Then what about BC? You go into the last page of that, you attach as appendix. Okay, appendix means extra information. Extra information. So this one, appendix, you just show. This one is calculation for experiment 1. So let's say value A. There's a formula. A equal to B plus C. Then you substitute value. 10 plus 15 equals 60. B, how to get. So this is the detailed calculation. You don't need to put your detailed calculation here. Only need to show how you do it. One sample only. Then the rest, detailed calculation is at the appendix. Okay. So here, discussion. How to do discussion. Look for the objective. You're answering the objective. So objective is inside the manual. So each experiment have their own objective. They must be answering why you conduct this experiment. So you use your data, use value to justify your results. For example, avoid using A is, let's say A value A sample is harder than B sample. Put question mark. If you do not explain this one, you just use a very general terms. Put question mark there. You'll have a very low marks for the report. You need to answer how you know harder. Give value. You measure some value in the experiment. So tell your lecturer why you put a statement why A harder than B, for example. So this one can be your conclusion, but before you come to this one, you need to mention A in this experiment, for example, give you 50 Newton and B give you 20 Newton. So from the experiment, A is harder than B, for example. I don't just like one like that. So, and then avoid. In this one, avoid. This one is just a note. Avoid first person inside there. Don't use I, we, you, there in your report. Use passive form or statement form, right? What does it mean? let's say you put okay, you put sample under microscope, right? You watch under microscope. Let's say this is a microscope, so you look under here. So you see a sample here, right? So you don't write, this one is don't. I put the sample under microscope. Use this one, avoid use I, you with there. Use passive form. It's the same meaning, but use passive form. Start with object first. Then what you do? Adjective. So for example, how to change this first person statement to this one? The sample was put on the microscope, so on. Okay, so these are the things. Professor, hey, Dr. Ang, can I still use first person? You can use, it's just that it's not a good technical report. Okay, there's no wrong if you say, can I use first person when I go to work? You can. It's just that it's not that professional. For example, you buy a phone or laptop, there's a user manual. You didn't see user manual using IUV there inside there, or any user manual. You buy a television also, you don't see people use IUV there. Okay, unless it's too simple, then like even the IKEA things, it just use diagram to tell you what to do. Step 1, do what, step 2, 3. Okay, so these are the things that don't do. Okay, so result as the discussion you discuss. Important you answering the why you conduct the experiment. Then what are the trend that you see? What you see? What you see from the graph, for example. Then why the graph is like that? Right? What answering what? Why or how to improve? This one is solution. Mean you see a problems, the thing is for example is weak, then how you strengthen it, this solution. This is additional bonus mark. If you want to score high in your discussion, then you give graph, you just get very simple marks, because graph everyone can plot. But just that if you just give me graph without a proper one, I highlight a few mistakes that I see throughout the semester. So then just give me like that. Maybe A and B. You put in the report. This is very low mark. Very low mark. Answer or graph presentation. So what I expect from you as a university student, a good graph must have label. What is this graph? A versus B parameter. All right. So A versus B must have unit. A, let's say unit is meter. This one is time or second. Unit, label, unit. Then this one, you know there's a Excel, there's a scatter plot. You know scatter plot. You input data, then you become a dot there. Then only you add thread line. Add trend line. Thread line means pattern line. This one under Excel skill. So if you don't know how to plot graph, just go any YouTube channel, go and see how people do the graph. Okay, so this is important things. Choose the correct graph. Sometimes sometimes line graph is not able to see. Sometimes you need to do pie chart, bar chart, and so on. Okay. Then this one is the caption for that one. Okay. Now, caption, there are two types. If you are looking at table and photo or features, is different. Table is here on the top. Table 1, then what is this? If it is a photo or features, it's at the bottom. Features 1, what is that? So this is how you put your caption. So this one is without caption, without unit, without label. I don't know what you plot. I only see lines, so I put question mark there. What is that? Okay, so these are the some mistakes or things that contribute to a very low marks in the coursework. Okay. Caption is below. Below the graph. Below the graph. Of course, here you got the, if you plot graph, there's a label for the graph, but for the all graph there is a caption there. Yeah. And also some photo. Okay, so if you want to score more marks, try to convert this one into another kind of graph. Means you extract this one from raw data. You see this trend, but can you make this graph into a more useful graph? Means you can convert, for example, this one to maybe pie chart. Some pie chart, or you can use it. Sometimes A and B doesn't tell you any value, for especially if you see a polynomial graph. You know polynomial, right? A graph, you have a linear graph, y equal to mx plus c, and polynomial, you have ax squared plus bx plus c, and polynomial, you have the axn plus bx something plus something, right? And you know that you can convert this one into log graph. So maybe you are getting the polynomial from raw. Can you convert this one to linear graph or not? Because this one, maybe you cannot see anything. But once you convert this one, maybe it give you this graph. Maybe. So there's some effort there if you want to score high. So if you just give this one, then maybe 10 marks, you get 5 marks. Okay. Then means you are at the edge of failing the lab report. It depends. If you do not discuss properly, I will just fail your lab report. But you do a lot of discussion, but maybe you're weak in the graph, I still can help you a little bit. Okay. These are the things. These are the things that we expect in your lab report. Okay, lab discussion. This one. Methodology, normally maybe maximum 2 pages, including the photo. Or if you look at the text only maybe 1 pages, but if you include a lot of photo, how you do it and label properly, your this one. For example, this one. So you can go to your photo. You can use some editing tools, Paint maybe. You label. This is maybe something. This is a platform or something, right? Or you can use this one is sample, something. Label a bit. Okay. Okay. So these are the things. What else? Okay, result discussion, reference, appendix. Okay, all right. So I'm going to show you how to do the referencing. Okay, how to do this one and then become here. So I'm showing you using Microsoft Word. Quite easy. Okay, your report submit in the Microsoft Word format. Oops. So you using Microsoft Word. Lab report is group submission. Group submission. We'll decide how many people in one group. Because I think the limit's still not stable yet. We wait until maybe after week 2 or week 3. Then we decide how many people in one group. Okay. Now, for example, how to do the citation? The samples A, or the sample A, which is an aluminium having uh, uh, tensile strength of something, right? 100. So let's say this one you abstract from a textbook. So how you do textbook, for example. Okay, let's say I copy from data from here. Just simple. Okay. Okay, let's say I copy this one. I need to rewrite this one. Okay, I need to rewrite this one. Don't copy and paste like this, because I will. Oh, okay. Oh, okay. So you open your Microsoft Word and then you go to a textbook. For example, you open one textbook and you copy a line from here. Don't copy paste. In this case, I just show you how to do it. So this one, blah blah blah, and you don't copy paste because I will put in the turning in, so it will detect all this. So how you do? So you just rephrase this one. Okay. So let's say rephrase this one. You write. Okay. Let's say this one after you rephrase. After you rephrase. Then you need to put citation, right? Okay, straight away you go to the top here. Go to the any Microsoft Word, you have these references. Go to the top here, click this one, insert citation. Of course, before you insert, there's a format here. Click this one. So usually we use APA. Of course, you can use, my personal preference is IEEE. You can use APA and IEEE or Harvard and Chicago also, but usually we use APA. So you choose APA, then because you this statement you copy from a textbook, right? So you go insert citation, add new sources. Once you do this one, you go to insert citation, add new sources. Then here you just work from the top until bottom. You just fill in the blanks. So let's say this statement I copy from books. There are lots of sources there. Right, lots of sources there. So a book section, conference, journals, and so on. So in this case, I copy from books. So I go to books. Then sometimes I try to open this one. Show all publication. You will see the red star. Red star is an important one. Okay. Now author, just go to the textbook. For example, this one. Author is James F. Fraxford and this one. So you copy from the textbook. Copy, Control C, go to here, Control V. Oh. Okay, then title of the books, you also copy. Introduction to Engineers. titles. Introduction to something lah, to something. Years, go to here. Years is usually below the textbook here. So there will be a date in the textbook. Let's see. Okay, so you see this copyright here. So copyright 2015, or sometimes inside here, you see, it already give you how to cite the books here already. Introduction to something, slash something, 8th edition. Years here do not have, but here you can go to the copyright just now. And sometimes when you download a textbook, they'll tell you what year is this. So this one, I will write 2016. You see, edited to, okay. So here, I'll just put 2015, 8th edition, referring to the copyright here. Okay, put the copyright here, 2015. Some textbook, they will write the print when. This textbook do not write print when. So I'm just using the copyright. So I go here, year, I write 2015. City, go to the textbook, it will show you where. So usually in the cover there, it tell you where is it. 8th edition, I see University of California, Davis, you just copy this one. Or sometimes you can just go to the below there, you will have a citation here, California Davis, you just copy, paste here. Okay, publisher is who publish, usually is the textbook thing, Pearson Education. You can copy only the front one because Pearson Education is one of the publisher throughout the world. So you just can put Pearson or Pearson Education. Publisher. Okay, volume. No volume, this edition. Important is the edition. Here. Okay, edition. This one is 8th edition. How you know 8? You go to the cover, you can know already. Okay. 8th edition at the bottom there. At the cover, they will tell you. So here, go to edition. You just put 8 like that. Okay, so let's say you copy from a page, right? Just now, I forget which page already. You just remember, you go to that page. Each page have their own, for example, textbook have their own, this one. Or page on the top here, 52 out of 658. Okay, now 33, section 2, something like that. So here, you go to the pages there. There's some page there. So put pages 35 for that particular statement. Okay, the rest is okay. Then you press OK. It will directly put like this. It will already put like this. Appeared here. So this is APA format citation. Then you go to the last page. Go to the last page of your report. Or you can just copy paste from this one. Last page is your reference. Reference of your report. Okay. Here, what you do, you don't need to do anything. Just go to the top there. You go to here, below the APA, publication there. Extend this one. There are lots of format you can choose. You can choose either biblication, references, work cited, choose references. It will come out directly in the reference section. So this one, you can either write one document, then you paste into the your report lah. Okay, or you need to remove this one. So you can directly use this format references and this one. So this is how you do citation. Okay, so let's say, okay, so Dr. Ang, I key in some wrong, let's say I key in the wrong years. How can I edit the things? So I go to the manage sources here, manage source. So I go and find, because this one have a lot. Just now is what? Okay, stack fault. How you edit? You go to manage source, you search for this one, you paste in the author name, go here, click this one, click edit. So you go back to this edit source here. So let's say I key in the wrong year. I go to the year, I change to 2016, I click OK, I press OK, yes, click close. You see what happened? It will change for you here, and also go to the reference here, it will change here. Here, you see it didn't change, right? So you need to go to this section, right click your mouse, right click, not right click. So on the top here, update citation and publication, there's a exclamation mark there. Click this one. It will update for you. Okay, so this is how you do citation. Okay, so we have done with the lab report session. So you don't know how, no more complaint. You don't know how to do. Okay, so this one we record as the first lecture. Okay, I need to show you this one. Then maybe 10 more minutes. Then we call it a day. Okay. Now same. There's no prerequisite for this subject. Then again, lab report. Make sure you wear cover shoes when you go into the lab. Cover shoes and long pants, things that because you might cut your legs, very sharp, lots of sharp parts. Okay. Again, you already see the course structure inside Canvas. Lots of information. You can go there, download. There are 4 learning outcomes here, which is important. Why? Because this is how we set question for your test 1, test 2, and final exam. Again, you have 4 learning outcomes. CL1, you learn about crystal structures. You look at the molecular dimension, right? How the crystal structure affect the material. This will be test 1, question 1, question 2, question 1, test 1, question 1, question 2. So question 2 will be CL2 related to mechanical properties. Okay, so this one will be test 1. Test 2 will look at CL3, CL4. Test 2, question 1, question 2. You look at phase diagram. You look at graph. Then question 2 will look at polymer, ceramic, composite material. Electrical, electronics, it depends on whether we have time. If we have time, then we go into this chapter. If not, then I will attach the information for you to read. It won't, if we cannot, we're not able to cover this one will not come out in your test or final exam for electrical characteristics, right? And then your final exam, 4 questions, question 1, 2, 3, 4, according to the learning outcome. Okay, so this is my name and my contact. All right. Same, my consultation hours is lunchtime. So if you want to see me, WhatsApp me. Right. Again, tell me who are you, because lots of spam out there. Okay, this is how it works for your assessment. T60, 40 coursework, final 60. Tasks, we have 2 tasks for this semester. Test 1, 10%, test 2, 10%. Combined, you get 20%. Individual assignment also, it will be 10%, very easy to get. It will be from all the question that we discussed in class. I will extract the question from the PowerPoint slides. Okay. Again, don't copy 100%. Before you copy, read and make sure the answer is correct. Because sometimes I will purposely put the wrong answer in the lecture and will ask you, did something wrong with the slides? Okay. So this one is very easy to score. I will release this. This one already released in the Canvas, but of course, we haven't teach you anything yet. So this one submit by week 10 or week 12, something like that. We will decide the due date later on. Okay. The actual submission already put in the Canvas. If you go into the assignment, you go to individual assignment there, I put in the due date there. So there's sufficient time for you to finish the assignment. Lab report already discussed just now. Lab report 10%. I think 6 or 5 experiment. There are 2 sessions. One is in the civil lab. We will look into the mechanical properties. Then the fab lab there, we will look into microscope, material hardness and all this. Okay. So this one, again, this one is a group submission, group report. Last semester, I failed one student because failed one whole group because the group consists of 2 persons. These 2 persons do not communicate. The whole group only submit 3 experiment report. So it failed the lab report. Okay, so it means 10 marks, maybe only get 3 marks because you submit 3 report. Maximum mark I can go. So it failed the lab report. Okay, so this is how we do. And then I already brief how to do the lab report, how to do citation, and so on. Final exam, the correction here is not 5, it's 4. Okay. 40%, you need to score 40% in the final exam question. 4 question, right? 25, 25, 25, 25. We add minimum, you need to get 40 out of 100 in final exam to pass the module. Then second criteria is a combination of coursework and final combined. You need to get more than 50%. Okay. By week 13, by week 14, you should already know how many marks you get for your coursework. Okay. Right, so this is how we do. There's lots. I think there are some sub-chapter there. Every week we'll cover at least 1 chapter. I will pull mechanical behavior earlier a little bit because your CL2 cover in your test 2. Test 1. Test 1 will be in the week 7. So it means after your Chinese New Year holiday that week. Okay. Then your test 2 will be around week 13. Then week 14 will be revision. Okay, so that will be the things. So this will be the reference books that we will be using. Okay, so these are the textbook they can use for your lab report actually. So go and find this textbook either in library or you can buy online. Right? So go and find, for example, you do mechanical properties, you go to the mechanical properties chapter, try to extract the literature review section here, the theory. Don't copy paste. Try to rephrase it. There is a smart way doing it. All right. A software called Qbot. For lab report, I'm not very particular in how you write your literature review, but I only want to see you are actually referring to textbook. That is more important to me. All right. I will refer highly on the result discussion here. This one, you can use Qbot, but the main ideas must come from you. Qbot is just help you on the grammar and rephrase all these things. But the main keyword must from here, from yourself. Or from your group members discussion. Okay. Yeah, keyboard is a way to go around with the turning in, but yeah, try to avoid copy and paste kind of things. That is what we don't want to see. Okay. Maybe go in a little bit on the theory, on introduction. So why we study engineering materials? So I myself in this area, for example, they launch all these Orion, these space vehicles into the space. So during the operation, they come in atmosphere. There's a thermodynamic process. So you need to choose the correct material for the operation. So for example, this spacecraft here use different kind of material in the operation, right? Including the shield, all these things. In fact, if you go into this material, you're expert in this one, you'll be headhunted. So this area is, if you're good in engineering materials area, especially nanotech or advanced materials, smart materials, then that is a trend. That's a trend for that one. Okay, this one you read. You read. So at the end of this, most of the question that you see in test 1, test 2, test 3, you need to answer why. Why you use a certain material, how you improve it. So there's a series of calculation. After the calculation, the question will ask you, based on the criteria, from the table that is given, let's say 10 material, select maybe 3 from that meet the criteria. Okay, general idea is to test you whether you understand what you learn and what, for example, what mean by 100 Newton, what mean by 200 megapascal. You have to understand all these values. What does it mean? Okay, so this one you read. Okay, so this is a civilization stage, Stone Age. So all these weapons that we use or tools that we use are from the evolution of technologies. From Stone Age, people start to use organic things, use animal skin, all this for the operation, dairy operation, to create weapons. And then when people discover metals, then people create metals tools. Then people discover black powders, then people go into war and so on. Okay, so these are the Stone Age, Bronze Age, Iron Age, and so on. So your job in this module basically is to answer what material to use for a certain process. For example, your customer give you an operation, you want to pull a metal to a certain length. So based on the properties, what kind of metal they're able to pull a certain length. For example, you need to answer all these kind of questions. Okay. Okay, so these are the information. This one also for your reading, right? For your reading. These are the very popular element that you'll see throughout the semester. Oxygen, aluminium, iron, potassium, magnesium, nitrogen, oxygen, argon, carbon dioxide. These are the popular member that you see in the question of the test 1, test 2, and final exam. Okay, so yeah, and 80% of this module you deal with metals, metal element. Okay, then all these things you read all the what are the engineers do, how engineering material link with the job, and so on. So this engineering material is basically to study the properties of material And then you should able, by the end of the semester, you should able to give a reason of selection of material. Why we choose this material? Because this module will help you in the senior years. For example, you come to the EDP, engineering development projects, or engineering design projects. You need to come up with a new design to achieve something. So one part of it is material selection. So what you use in maybe year 4 or year 4. So you will need some analysis for that. You apply what you learn in this module. Okay. All this you read lah. So these are the latest hot things, Mars exploration, right? So try to link your projects to all these new latest trends, so that when you go to work interview, at least you can impress your interviewer. You actually using what you learn in universities, link with the latest trend. For example, space exploration and so on. Hydrogen engine. You know that Malaysia now we are developing hydrogen gas. So and then some sustainable energy, biofuel, solar panels. Solar panel also they are using quite extensive in knowledge of engineering materials. All these things. Okay, so these are the general ideas or application of materials. These are nanomaterials. Nano means 10 power 9, very, very small. So these are the application. This one also for your information. So at least this introduction will give you a general idea. There's a reason why we take this module. Okay, so this is a current trend. Current trend, including if you're driving cars. Nowadays, you polish your cars with this rainwater resistant. That it will give a low drag to your mirror, glass surface. So that one, the polishing element, that one also under engineering, nanotech. That one is under nanotech technology. Right? Composite, this one, your handphones nowadays, lots of nanotech also. Okay? Okay, the differences between material science and material engineering. Science is more on knowledge, right? So those in the Faculty of Science, Lab Sciences, they cover extensively on the theory. If you add engineering behind something, it's more on the application. You learn, then you apply. Then you should be able to explain why you use a material or why you use it. Okay, so engineering material is actually application of the knowledge, so that you can meet the consumer needs, or you can convert it into a useful products. Material science is just stop at the experiment, then come up with a theory and so on. Okay. So this is a basic diagram for material science and material engineering. So you combine. Some universities they offer material science and engineering, so they actually combine these two. So for this module, again, we are engineering materials. So engineering materials, we are heavily focused on applying the knowledge. So most of the question you see in test 1, test 2, and final exam is why. You need to answer why. So you do calculation, then you answer why. Or how you apply, how you improve it. Or through calculation, you explain the steps. Should you pull it this way or pull it this way? Step 1, pull this way. Step 2, pull that way. Why? Okay, so on. Okay, this one you read lah. So you read. This is the area of science and materials and so on. Okay, properties. So mechanical properties is part of the module. Electrical properties also part of the module, but this one is later. If you have time, you go into here. If not, then it will cover in the Dr. Zuraida class, more on the electronic circuit, that one. Thermal properties, a little bit. Magnetic properties will not cover in this module. But you will look into microscopic level. You look into the orbit of the electron and so on. That one. Optical properties, this one is on visual. We will not study this one, optical properties. But it can be part of your lab explanation, right? You observe the object, then you see, so on. Deteriorative characteristic, this one is under corrosion engineering in the elective subject in the senior year. So if you studies, if you take the corrosion engineering, then you will focus on deteriorative characteristics. So these are the placement of the same material, aluminum oxide, but the properties of the visual is different. So try to be familiar with how you describe your sample: transparent, translucent, and oblique. Okay. So when you write your lab report, try to use some scientific words. Scientific words. So we will study why an object look like this in terms of their structures, molecular level. So these are the 4 key words. We will study processing, how you process material. Processing, like for example, you want to cut aluminum very easily, you want to cut titanium very hard. Why? It's because of the structure, molecular structures that give you the properties and give you the performance. So basically, these are the 4 areas that you'll be asked in a question. Either you'll be asked how to process it, process 1 do what, process 2 do what, or you look into structures. This one normally question in your test 1, question 1 or question 2, ask you about cluster and properties. Performance, this one will be in the later chapter. It's a combination of these 3. Okay. Okay, I think we stop here. Next class, we will go into type of material. Okay. Next class will be when? Will be Wednesday, 8 to 10. Wednesday, 8 to 10. Okay, we will remain our time schedule. We won't change. Because Thursday is only like, you only go in for, let me stop the recording first.